Now we're going to start to get into the specific reaction types. So the one we're going to start with is a substitution reaction. It's going to look different just because we're drawing these structurally rather than just in their formula state. But there's a lot of similarities to, let's say, like a double replacement, where something is changing places with something else. So if I was to draw out an example here, let's say you started with a propane molecule like this, and we're going to add it to a bromine molecule. Now what's going to happen here is they're going to switch places. So let's say, as an example, let's say this first H right here is going to switch places with this bromine right here. Oops, come on. Like that. Okay? So what you're going to end up with in the end is the same 3-carbon parent, except now one of those H's has been replaced with a bromine. Now you've got a 1-bromopropane instead of just a propane. And you're going to have an HBr there as well. Now, it didn't have to be that H that it switched with, though. So another option could have been that maybe this H switched places with this Br, and which Br doesn't really matter because it's still going to be an HBr, just flipped around. But the idea here is that now we have a different possible product. So we could say, or we might end up with a 2-bromopropane if it switched with a different hydrogen on the molecule. Now, if you go farther into chemistry, you'll learn about whether the H's on the end carbons are more likely than the middle carbons, and there's a whole bunch of rules that go along with that. But it's beyond what you need to know for Chem 30. You should, though, be aware that you could get either of these two products, and either of them would also come with HBr as a byproduct. So it's just a switching places. It's just one of these or one of those, a switch. Okay. Now with the alkanes like this, it's typically going to be, the condition is it needs light, or sometimes it's just written as UV. It needs that energy in order to make that switch of a halogen with a hydrogen is typically what's needed. And I would write this in your notes there, I guess the first point there, a hydrogen atom on a saturated hydrocarbon, which is the alkanes, or benzene. And I'll show you that example next. So these are the only two families that do substitution reactions like that, is the alkanes and benzene. If it's benzene, though, it's a little bit different. Instead of having light or UV energy, it needs a catalyst. You don't have to worry about what specific catalyst it might be, but in this case, let's put light and iron 3 chloride, so FeCl3. So again, you'll never need to know that. But that catalyst needs to be there because of the stability of benzene to make this work. And kind of the same idea here, we're still going to make that switch. Let's say this H right here is going to switch places with that chlorine right there. And so we're going to end up with a chlorobenzene and an HCl in the end. Okay, so it's just a swap. This sometimes also happens with alcohols. So let me go back to this. So let's say we have an ethanol like that and an HCl. So in this case, halogens and hydroxyl groups, that OH is the hydroxyl group, for whatever reason, they like each other a lot. And so if anything here is going to switch, it's probably going to be that hydroxyl group and that halide group, that chlorine. So they're going to be the two that switch places if anything's going to switch places. So in the end, you'll end up with a chloroethane instead of an ethanol, and then water. Okay. One more time that this happens is sometimes this will happen if you've got a halogenated alkane in the presence of a strong base. So not a hydroxyl group, but a hydroxide ion, because it's a base, not an alcohol. If that happens, these two things are still going to switch places. They're just all about each other. I don't know why. They're still going to switch places, but in the end, what you end up with is a ethane or an ethanol, but then you're also going to end up with chlorine just kind of by itself as an ion. So that's one little variation that happens there. But again, just know that if there is an alcohol or a hydroxyl group and a halogen group, they're going to be the very most likely to be switching places back and forth. Okay? Hopefully that makes sense. If there's anything there that I went through too quick, or if you need some more examples, just let me know and we can go through it. But that's the substitution reactions.